and today we will so electric train and nature of traction drive and duty cycle of the traction drive. Okay. So in the last class we have studied about the traction drives. In that we have studied electric train, electric locomotive, and then the nature of the traction load and the duty cycle of the traction drive. Okay. So we will again draw the duty cycle of traction drive. So this is curve between speed and time. Okay. So we will derive the distance traveled by the locomotive from traveling to one station to another station. Okay. So initially it is at 0. So it will accelerate. Okay. Constant acceleration will be there. Okay. From the start. And at this point it achieves the base speed. Okay. And then this region correspond to constant torque region. Okay. So initially when train starts, so it accelerates with constant acceleration and torque is remain almost constant up to when base speed is achieved. Okay. Then it accelerates further with constant power. So this region is constant power region. Okay. Then after that, here drive torque will be equal to load. Okay. So this is steady state. The steady state is achieved, and then this will freeze like this. Okay. So this is free running of the traction. Then we switch off the motor here. Okay. So this is coasting train. So train will coast due to its inertia, and then we have to stop the train. So we have to apply a negative torque to stop this motor. Okay. So this is braking. So this we have covered in the last class. Okay. So this is constant torque region. This is constant power region. This is free running, and this is coasting, and then braking. Okay. So let suppose this is point A. So the area beneath this curve will give distance traveled. Okay. So we have to find the area of this curve in order to find the distance D. D is equal to distance traveled in kilometers. Okay. So we will find the area of this curve. So for simplification, we assume this curve to a trapezoid. Be a trapezoid. this dotted line represent this curve as trapezoidal. Okay, so we are assuming this curve as a trapezoidal curve. Okay, and if we draw a tangent, okay, on this curve from this curve, so let this point as B. Okay. Dotted line. Okay, and this point is as C. This is C. This is point D. This is E, and this is F. Okay. So let's suppose alpha is acceleration in this constant expression. Alpha is equal to acceleration. Okay, and beta is deceleration. Okay. And units are kilometer per hour per second. Similarly, kilometer per hour per second. Okay. So what we have assumed? We have assumed that alpha be the acceleration. Okay. And beta is the deceleration, and units are in the same kilometer per hour per second. Okay, so let divide this. So let's suppose this total time taken to travel from A to B, from one station to two station, from A to B, from one station to another station. And let's suppose this time period is T1. So this is for acceleration, and this is T2 for free running, and T3 for braking. Okay. So let T is total time of travel. Okay, let's suppose T is total time of travel, and T will be equal to capital T will be equal to T1 plus T2 plus, okay, this will be total time period T. Okay. So now we have to find the area under this curve, and this will be area within this curve. Okay, so we have to find the area. So first we will find T1 and T3. Okay, so this we have what we assume. This is alpha, and let's suppose this Vm is maximum velocity. Okay, so maximum speed. So Vm is maximum speed that this locomotive can attain. It is kilometer per hour. Okay, so we are assuming Vm, velocity of the train, kilometer per hour. Okay, so T1 can be calculated. T1 will be equal to Vm upon alpha. Okay, so what is expression is equal to velocity divided by time, speed divided by time. Okay, and similarly T3 is for deceleration, so this will be Vm upon beta. Okay, so the velocity time period for acceleration will be equal to speed upon acceleration, and this is time which is referred for deceleration or braking. Okay, so T3 is equal to Vm upon beta. Okay, so D will be equal to this D time travel will be equal to area of the this trapezoidal. Okay. Curve. Okay. This trapezoidal curve. Okay. And this trapezoidal consists of this triangle, then this square, and again this triangle. Okay. So this will be equal to so this triangle. So this is like this. Height is Vm and its base is T1. Okay. So the area of this triangle will be equal to half Vm into T1 plus this is a square, length is Vm and breadth is T2, so this will be Vm into T2 plus again this triangle is Vm, this is Vm and this is T3, so this will be half Vm into T2. So this will be the area of this trapezoidal curve. Okay, so we take Vm out, so this will be T1 upon 2 plus T2 plus T3 upon 2, or this will be equal to Vm divided by 2 T1 plus 2 T2 plus T3. Okay, so this will be equal to Vm upon 2 2T minus T1 plus T2. Okay, because T is equal to T1 plus T2 plus T3. Okay, so you can write as Vm upon 2T1. So this will be 2 T1 plus T2 plus T3 minus T1 minus T2. So this will give T1 T3 plus 2 T2. Okay, so since we know the value of T1 and T3, we can substitute here. Okay, and this is in kilometer per hour. So in order to convert it to in seconds, so this will be multiplied by 1 upon 3600. Okay, so this will be equal to Vm upon 7200. So this is multiplied by so 2t minus t1 plus t3. Okay. Now substitute the value of t1 and t3, we will get, so distance travel will be equal to Vm upon 7200 divided by 2t minus Vm upon alpha plus Vm upon beta. Okay, so this is the expression of distance traveled by the locomotive. Okay, so D is equal to Vm upon 7200 into T is total time traveled by the locomotive. Vm is the maximum speed, alpha is acceleration, and beta is deceleration. Okay, so in this way you can find the speed, distance traveled. Okay. So now next we will study the important parameter is coefficient of adhesion. Okay. So this is one of the important parameters in traction drive. Okay. So the task of a driving equipment consists is to carry the carriage. Okay, it has to pull the coaches and the trailers which are connected to the engine. Okay, so and there should be no slipping of the wheels. Okay, so the wheels should run on the track. Okay, so wheel is coupled to the motor either directly or through reduction gear known as driving wheels. Okay, so this is the wheel and this is the tracks. Okay, and it is the point of contact. Okay, and this is X. Okay, so these are wheels and these are tracks or rails. These are big rails on which these wheels run, and these are connected to a axle. Okay, and motor is mounted on this wheel which drive this axle, and this axle will drive this wheel. Okay, and so motor can be directly connected to the axle or through reduction gear arrangement. Okay, so these are gears. Okay, so this is how the wheel rotates. So two wheels are connected through axle, and our motor is mounted on this axle, and it is connected through reduction gears. And when motor moves, this gear moves, and it will move the axle and the this wheels. And there should be no slipping of these wheels on the track. Okay, so this the grip of the wheel on the train on the track, it should hold this track when it run on this rail. Okay, or the track. So there should be adhesion between wheel and track. Okay. So adhesion is something analogous to the friction. Okay. So there must be a friction between these two wheels and tracks. And if there is no adhesion, so this wheel will slip on this track, and there will be no forward motion of this wheel. Okay, so there should be adhesion between this wheel and tracks. Okay, so these wheels So on this wheel, there will be some tractive weight. Weight will be exerted on this okay. So some weight will be there. Okay, weight of the so this is given by m into g. Okay. So weight on the driving axle is also weight on the driving wheel, also known as adhesive weight. So this is also known as adhesive weight. Okay. So weight on this axle or driving wheels. So these wheels are also known as driving wheels. Okay. So weight on this driving wheels is known as adhesive weight. And the tractive effect is total force on the rim for driving wheels, and the torque, the tractive force or effort is equal to torque divided by radius r. Okay. So r is the radius of this wheel and T is the torque. Okay, that is produced. This is tractive torque. Okay. So this is tractive effect is given by Ft is equal to T upon R. Okay. So tractive effort is directly proportional to the torque. Okay. So when motor runs, drive wheels exert frictional force in the backward direction, tangentially in the backward direction. So this is frictional force. Okay, so when motor drives, so so there will be a reaction on this wheel, and this will move this this wheel in forward direction. Okay, so in this manner, this wheel rotates. Okay. So what is coefficient of adhesion? Is equal to maximum tractive effort that can be applied without slipping of the knee, whole divided by weight on the driving axle. Okay, so this is maybe given as CA or mu A. So this coefficient of adhesion is quite similar to coefficient of friction. Okay, so this is analogous to coefficient of friction. Okay, so in traction we generally call it as coefficient of adhesion. Okay, so coefficient of adhesion we define it as maximum tractive effect that can be applied without slipping of the wheel. Okay, so there should be no slipping of the wheels divided weight on this driving axle. So this is our driving axle and this is the weight. Okay, so there should be so this is the maximum tractive force that can be applied uh, without any slipping of the wheels divided by the weight of the driving axle. Okay. So if there is a slipping of this wheel, so there will be increase in the speed of this wheel, and this both this wheel and this track will get damaged. Okay, so this wheel is made up of steel, and this track is also made up of steel, and there should be no slipping of this wheel. Okay, so if there is any slipping of wheel is there on the wheel, so this will cause damage to both wheels and the track of the rail, and this is known as burning of the track. Okay, so there will be friction, and due to which there will be wear and tear of both the track and the wheels. Okay, and this is generally referred as burning of the track. Okay, so at the point of the contact, so here, so this will be burning of the track. Okay, so we have to make sure to we should apply the maximum permissible tractive force. Okay, so in order to avoid slipping of these wheels, so we have to apply only the maximum permissible tractive force. Okay, so to avoid this slipping of the wheel on the railway track, so we have to apply the maximum permissible tractive force. Okay. So this coefficient of adhesion depends on many factors, such as now we will study the factor affecting the coefficient of adhesion. So coefficient of adhesion depends on first type and condition of surface. Okay, so it depends on the type and surface of the type and condition of the surfaces at the point of contact. Okay. Second, it depends on vehicle speed. Okay. Third, it depends on nature of torque speed characteristics. Okay, so we use different motor, so it depends on torque speed characteristics. So different motors have different torque speed characteristics. And then fourth is motor connection. So in traction, one and more motors are used, so it can be series connected or parallel connected. And last is type of power modulator. So it depends on the response of the power modulator which is used. Okay, so these are the factors which affect the coefficient of adhesion. Okay, so we will see each factor one by one. Okay, and we will discuss it in detail. So first we deal with the type and surface at the point of the contact. Okay, suppose this is wheels, this is right, and this is point of contact. Okay, so the coefficient of adhesion is depends on the surface type or condition of the surface. Okay, if there is oil on the track or grease is present. Okay, so if there is any oil is present or grease is present, so this will increase the slipping of the uh, wheels. Okay, and if there is a slipping of the wheels, so CA, that is coefficient of adhesion, will decrease, will reduce. Okay, so due to the presence of oil and grease on the track, on the railway track, okay, so this wheel will slip and this will decrease the coefficient of adhesion. Okay, and if there is water is present in rainy season or there is a snowfall, so this will also decrease the coefficient this of coefficient of adhesion, or mud is present on the surface of the track. Okay, so all these factors will gradually reduce the CM. Okay, so during the rainy season, water will be present on the railway track, and if there is snowfall, so there will be snow on the track, and if mud is present on this track, so this will decrease the coefficient of adhesion. Okay. So next is vehicle speed. Okay. Okay. So first we will see the variation of speed and speed variation with respect to CA. So this is plot between speed and coefficient of adhesion. Okay. So from this curve, it is quite clear for higher speed, the coefficient of adhesion is less. For high speed, CA is less. Okay, and for low speed, CA is greater. Okay, so this is the case for higher speed. When the speed is high, so let's suppose this is CA1 and this is CA2. So CA1 is less, okay, and when speed is low, the CA is high. So CA2 is greater than CA1. Okay. So coefficient of adhesion decreases with increase in speed. Okay. So CA decreases with increase in speed. Okay. So Now we will discuss third parameter, third factor, which is nature of torque speed characteristics. Third, nature of speed torque characteristics. Okay. So CA will be high with low regulation of speed. Motor with low regulation of speed. Okay, as torque decreases, so motor will regain the grip. Okay, so let's suppose motor whose torque speed characteristics is like this. Okay, this is the speed. So and this is torque. Okay, so this curve speed torque characteristics is quite similar to separately excited DC motor. Okay, so where speed regulation is very low. Okay, so here let's suppose the wheel slips. Okay, and when wheel slips, speed will increase. Okay, so there is little change in speed. So this is the operating point 1, and when train slips, so the operating point is to point 2. Okay, and corresponding torque is this is T1 and this is T2. Okay, so when wheels slips, so the speed changes, it increases, so it changes from 1 to 2, and corresponding value of torque is T1 and T2. Okay, so there is change, there is quite significant change in torque. Okay, so T2 is less than T1. Okay, so torque is reduced, so tractive effect will all the force will also decrease, and wheel will regain its grip on the track. Okay, so it will regain its hold on the track. Okay, and if we consider another speed torque characteristics, somewhat like this. Okay, so this is characteristics of DC series motor. Okay. So this is speed and torque. Okay, so again, if there is change in speed, there is slip of wheel is there. So let's suppose this is 1, and when wheel slips, speed of motor changes, increases. So this will be 2. So this is T1 and this is T2. Okay, so you can compare from these two graphs. So change in torque is quite less in case of DC series motor as compared to separately or shunt DC motor. Shunt DC motor has characteristics somewhat like this. Okay, so the CA will be high in case of separately excited DC motor, and CA will be low in case of DC series motor, because the change in torque is very low. Okay, so there will be a low torque change, so there will be low change in force. Okay, so there will be low CA, coefficient of adhesion will be less in case of DC series motor. Okay, and in case of separately excited DC motor, it will be quite high. Okay. So when wheel slip, speed will increase. Okay, speed increases, but torque reduces. And active force, because Ft is proportional to T. So T reduces, so Ft will also reduces, and wheel will regain its speed. Okay, so therefore Ca will be high. So there will be no slipping, and in this way the slipping can be avoided or prevented. Okay. So next we will see motor connection. Fourth is motor connection. Okay, so in traction drive, more than one motor is connected. Okay, so this motor can be connected in series or in parallel. Okay, or combination of series and parallel. Okay, so we will see the effect of this combination on C. Okay, so this is coefficient of addition. So when motors are connected in series, will lead to high, low CA. And when motor is connected in parallel, it will lead to high coefficient of addition. Okay, why? Because when in case of series, okay, when there is a slipping of field, so for series connection, so all motor are connected in series, so speed increases. So back EMF also increases. Okay, and the current and torque will reduce. But current and torque will reduce of all the motors. Okay, so if all the motors are connected in series, okay, so if there is a slip of wheel of this motor, so this will slip of this motor, this wheel of is connected to this motor will reflect to all the motors. Okay, so if there is slip of one wheel, so all the motor current and torque will get reduced, and this will lead to a low coefficient of addition. Okay. So this will decrease the total torque. So total torque will reduce. Okay. Due to one motor, the total torque is reduced. So this will lead to low CA. So the motor corresponding to a wheel which is not slipping, it also get reduced. The torque of this motor is also get reduced. So the total torque available will reduce. So this will lead to low CA. Okay, and all the motor will get affected. And for parallel connection, connected motor, current and torque are independent. Okay. So in case of series, current and torque are dependent, but in case of parallel connected motor, the torque and current are independent, and torque and current of the other motor will not be reduced. Okay, so the torque and current will be reduced of that motor whose wheel is slipped. Okay, so this will affect the motor on which is connected to the wheel which is slipped, but it will not affect the other motor which are connected in parallel. Okay, so the total torque will be higher. Will be higher, and hence CA will be higher. Okay, so if there is any means slipping is there, so it will reflect to only one motor. Okay, so this will not be reflected to the all motors which are connected in the parallel. But in the case of series connected motor, if there is a slipping of wheel of one wheel which is connected to this motor, so this will reflect to the all the motor which is connected to this. Okay, so there will be total torque reduction, and here the torque will remain higher as compared to series connection. Okay, so CA will remain high. Okay, so if we have let's suppose there are 4 locomotives. Okay, so best connection will be in taking this coefficient of adhesion in consideration. So bus connection will be connecting all 4 motors in parallel. Okay, so if you want the best possible connection, so taking coefficient of adhesion in consideration in the point of view of this CA, so the best possible connection is we connect all the 4 motors in parallel. Okay, and second best, you can connect 2 in series and then in parallel. Okay, so 2 motor in series, pair of the series connected in parallel. Okay, and worst is all 4 connected in series. Okay, so you should connect this motor in parallel in the taking into consideration the CA. Okay, and last is type of power modulator. Okay. So it depends on type of the power modulator which is connected. Okay. So if there is any wheel slipping is there, so wheel slipping detection gets command wheel slip detection get command. Okay, will get command for the reduction of motor torque. For the reduction of motor torque. Okay, and then so slipping of motor can be avoided and wheel regain. So there is a wheel slip detection circuit is there. We detect this wheel slip and which give the command of motor to reduce the motor torque, and then the wheel get hold on the wheel. Okay. So in the drive where torque can be reduced faster, tendency of wheel slip will be lower. Okay. So in a drive where torque reduce faster, the tendency of wheel to slip is low. Okay, will be low. So if there is torque reduction is fast, so then slipping of the wheel will be low. Okay, so torque will must reduce faster in order to avoid slipping of the wheel. Okay, so these all are the factors which affects the coefficient of adhesion. Okay. So in next class, we will study the calculation of the drive ratings and energy consumption. Okay. Thank you, class.